right, today we are wrapping up plate tectonics with plate motion. We've already talked about the number one most important mechanism for plate motion, and that is convection currents. The rising of warm mantle, spreading out under the crust, causing the crust to move, before that mantle cools off, sinks back down towards the core, where it heats back up and this process just continues. But that is the primary mechanism. There's also a couple secondary mechanisms we need to talk about as well. The first secondary type of plate motion is called slab pull. And this is all about subduction. Okay, we have that piece of ocean crust that is subducting into the earth, into the mantle. And gravity is pulling on that subducting part of the crust. But since that subducting part is also connected to the surface of Earth, gravity is pulling hard on the subducting piece, and it's pulling the entire plate towards the subduction zone. Almost like a belt being pulled by gravity off the side of a table. If you hang the buckle of a belt off a table, gravity is pulling on that part of the belt, and the rest of the belt that's flat on the surface of the table will spill off the table, off the side, just because gravity is pulling on that dangling piece of the belt. Ridge push occurs at a mid-ocean ridge. And those convection currents that are rising underneath a mid-ocean ridge actually take the ocean plate and make it stand up. They almost make it bulge. That causes the mid-ocean ridge, those mountains. And gravity is pressing down on that mountain range. But since the convection current is holding it up, the only place for it to go is to spread apart sideways. This is ridge push. It is the pushing down of gravity that pushes plates apart. Convection currents are holding them up, and gravity causes them to separate. The very last mechanism are mantle plumes, also called hot spots. And there are hot spots all over the world. There's something like 40 some of them, but the two that come to my mind are Yellowstone National Park and the islands of Hawaii. The volcano on the Big Island, the island of Hawaii, is formed because of a hot spot. And this is mantle material burning a hole straight through the crust that then erupts onto the surface. And the cool thing about mantle plumes or these hot spots is no one really knows why they are located where they are. The best idea is just some simple physics. For every action there is a equal and opposite reaction. So the idea is that our convection currents aren't quite balanced. That there is more mantle material sinking than there is mantle material rising in a convection current. So to balance that out, the mantle itself has to have other little areas of rising mantle, just to make those convection currents balanced and equal. And these mantle plumes, they never move. They are stationary inside the mantle. But this one mantle plume made all of the Hawaiian Islands. How can that even be possible? If the mantle plume doesn't move at all, how could it produce several different islands? I know you're thinking about it. I know you want to say it, but it's just simply plate tectonics. Our plates have moved over top of that hot spot. And as the plate moves over the hot spot, it produces a chain of islands. We can even use these old islands in the Hawaiian chain to predict where the newest volcano will pop up. So if you look and kind of extrapolate those islands, the best guess of where our next Hawaiian island would be kind of southeast of the current Big Island. So when it comes to plate motion, convection currents is the most important, but you can't forget the secondary motion like slab pull, ridge push, and mantle plumes. All right, make sure you have your notes filled out, and if you have questions, please ask. Thanks.